When a humanoid robot first rolls onto the factory floor, it doesn't arrive as a finished employee ready to instantly conquer the assembly line. It arrives as a trainee. I want you to just let that sink in for a second. For business leaders, this requires a fundamental shift in perspective. You are not simply unboxing a fully realized worker. Let's ground this concept right away in reality. A recent case in a Korean factory makes this learning curve incredibly clear. A small manufacturer there deployed a humanoid robot specifically for a precision auto parts cleaning process. And we aren't talking about a small tabletop robotic arm here. The robot trainee they deployed has a human-like scale, standing roughly 168 centimeters tall. It also weighs in at about 80 kilograms. So it brings a very real, substantial physical presence to the factory floor, designed to operate right alongside its human counterparts. It's specifically a sign job, to repeatedly lift and move parts baskets weighing just under 15 kilograms. This is work that's physically demanding, highly repetitive, and notoriously difficult to staff with human workers. Now, the company set a pretty rigorous target for this task, a 99.9% completion rate. But just placing the robot on the floor didn't make it instantly productive. In fact, it took about 6 months of continuous training before the robot was treated less like a newly purchased machine and more like a new employee who had just successfully passed probation. Which brings us to our first major lesson. Robot deployment is not simply a one-time hardware purchase. It's actually the building of a comprehensive job training system. Before a humanoid can perform useful work, it literally has to master 5 distinct areas. First up, it must learn the exact job. The company has to explicitly define the starting points, the sequence of actions, the precise quality standards, and the exact conditions for completion. Second, it has to learn the movement. Think about it: walking, turning, reaching, lifting, balancing, and carefully placing an object. All of these mechanics have to be coordinated into one seamless, fluid behavior. Third, the robot must learn from demonstrations. Human operators actually use virtual reality teleoperation, motion capture, or direct physical guidance to physically show the robot exactly how the task should be performed. Fourth, it must learn exceptions. The real world is messy. A basket might be tilted, the floor could be slippery, a human might suddenly step into the work area. The robot needs to know exactly when to adjust its grip, when to ask for human help, and most importantly, when to just stop entirely. And fifth, it has to master safety. This means defining safe speeds, maintaining safe distances, understanding strict force limits, and executing emergency restart procedures dynamically in a real, active workplace. This brilliantly illustrates our second major lesson. The most valuable output of deploying a robot is actually the data it generates. Every successful lift, every failed grip, and every single human intervention feeds a continuous learning loop. Real factory data is run through digital simulations under thousands of different conditions to output a constantly improving policy back to the physical robot. But to make that loop work, you really need human expertise. Experienced workers possess this tacit knowledge where they intuitively notice tiny changes in sound or physical resistance. A robot can't just read that in a manual. Companies have to convert that human know-how into measurable signals, specifically tracking finger position, joint angles, and applied force to build concrete decision rules. Let's move to our next point, which is absolutely critical for compliance. Under ISO 1021-8-2025, there is a strict distinction between a safe machine and a safe process. Buying a robot that is technically safe on its own does not automatically guarantee safe integration, safe daily operation, or a safe overall work cell. To summarize, companies need 5 essential operating capabilities: clear job design, high-quality demonstration data, a robust exception library, strict safety validation, and continuous post-deployment improvement. The ultimate robotics race won't be won by whoever simply buys the most expensive hardware. It's going to be won by the organizations that can train, validate, and improve their robotic workforce the fastest. Because the factory that builds the best training system is the one that will inevitably build the strongest competitive advantage in the market. This explainer was brought to you by eXGateAI. We are dedicated to turning complex, cutting-edge technology into actionable intelligence for CEOs and industry practitioners. In a rapidly evolving industrial landscape, we ensure you stay ahead of the automation curve by providing the deep insights you need to make confident decisions. We help you decode the future of manufacturing today, transforming raw data into strategic foresight that drives tangible business outcomes. But ask yourself this: if a robot takes 6 months of rigorous training just to learn how to move a basket, how long will it take your organization to learn how to manage a robot?